Section 6.4 is about proportional and non-proportional relationships. So we have a specific standard 7AF6 deciding whether two quantities are in a proportional relationship. So we will look at tables and we will also look at graphs. So first we have some vocabulary terms. Proportional means that two quantities have constant ratios or rates. So in the example, we have 3/1, 6/2, 9/3, 12/4. Hopefully you can see that those are all constant ratios or rates because they all reduce down to 3/1. Two quantities are non-proportional if the ratios or rates are not constant. So here you see we have 4/1, which is not equal to 6/2, not equal to 8/3, not equal to 10/4. And a constant of proportionality is a constant rate or a unit ratio of a proportion. And we'll use this a little bit in some of our real-world problems. So looking at a table, we want to try to determine whether the cost of coffee is proportional to the number of pounds, and then explain our reasoning. One thing you want to pay attention to is how it's worded. So it's cost to pounds. So when we write our proportions or our ratios, we're going to put the cost on top and the pounds on the bottom. So $3 for 1 pound, $6 for 2 pounds, $9 for 3 pounds, $12 for 4 pounds. And similar to the example in the definition, this is in fact proportional. These all reduce down to 3/1. And because they all reduce down to 3/1, this is proportional. So it's proportional because, and if you want, you can go back and look at the definition, the quantities have a constant ratio or a rate. Because there is a constant ratio among the data. Please make sure when you're doing these examples that you are copying the table into your notes. You don't necessarily have to copy the words up here with number 1, but please make sure the table is in your notes. Number 2 is asking if the number of miles is proportional to the number of hours. So again, it's miles per hour. So 50/1, that doesn't reduce. 70/2, if we divide by 2, we get 35/1. 90/3 reduces as 30/1. And 110/4 is 55/2. So you can see here that we have, if we compare, these are not equivalent. So this would be a non-proportional relationship. Non-proportional because there is not a constant rate, you can say ratio, among the data. Now we're going to look at a couple of real-world examples. We're going to find that constant of proportionality, which we also think of as the unit rate. So it says that the cost for 2.5 pounds of meat is $7.20. We want to write an equation that relates the cost to the pounds. So we want to know if I buy X amount of pounds, how much is it going to cost me? And then in the end, we want to also find out how much will 4 pounds cost. So the hint here is to find the unit rate first. So we want to know how much per pound. So we have $7.20. Remember, money always goes on top. And we have 2.5 or 2.5 pounds. So we're going to divide in a calculator, 7.2 divided by 2.5, and that's going to give us $2.88 per pound. This is your constant of proportionality. And I'm going to write that here. This is the constant of proportionality. So when we write our equation, we're relating the cost to the pounds. So how much will it cost if the meat is $2.88 per pound? And we'll use P for pounds. So now if I buy 7 pounds, I just plug in a 7. If I buy 52 pounds, I'd plug in a 52. The question here that we are also asked to answer is how much will 4 pounds cost? So that would be C equals 288 times 4. 2.88 times 4 is $11.52. So it would cost $11.52 for 4 pounds of meat. Example 4, we have Luke earns $54 after mowing 3 lawns. Write an equation comparing the earnings to the lawns mowed. And how much would Luke earn after mowing 7 lawns? So again, we want a unit rate. So that's 54 over 3. That's going to give us the unit rate. How much does he make per lawn? 54 divided by 3 is 18. So it's $18 per lawn. This again is the constant of proportionality. And I'm just going to abbreviate there for a moment. So now we want to write an equation that compares his earnings to the lawns mowed. So we're going to use that 18, and I'll use a cursive L for lawns. No, I'll use a capital L. So his earnings are going to be equal to $18 times the number of lawns he mows. And now the question is, he mowed 7 lawns. So it's 18 times 7. And that's $126 for 7 lawns. Now some of you might be able to do a lot of this in your head. You would do 54 divided by 3 or on a calculator. 54 divided by 3 times 7, you get 126, and you think that's the answer. What's the problem? We were asked to write an equation. So when you write the equation, you have to get that constant of proportionality, which is the unit rate. Then you also need the answer for mowing 7 lawns. So there really are 2 parts to this problem, so you can see why it's important to find the unit rate. Now let's talk about a graph. How to tell if a graph is proportional, and this is really simple. All you have to do is look at the origin. Once the data is graphed on the line or in the graph, then we just look at the origin. If the line passes through the origin, remember the origin is 0, 0 on a graph, we say that the data is proportional. If it does not pass through the origin, then the data is non-proportional. And then also another note is that in order for data to be proportional, it has to be a straight line. So ultimately all of these examples I show you today will be straight lines. So then you're just looking at, does it pass through the origin or not? So if you just want to try to draw this quick graph in your notes, is the graph proportional? So we're looking at the speed of a sloth. How far does it travel over time? You can see that this graph is a straight line, and it does pass through the origin, 0, 0. So yes, the data is proportional. And it's always important to be able to explain yourself because the line passes through, oops, zero, 0. You can also look at distance over time. This ordered pair is 3, 1. We have 6, 2. And we have 9, 3. So if we wrote those as ratios, 3 over 1, 6 over 2, 9 over 3, they all reduce down to 3 over 1. So again, that's how you would be able to tell from the table that this data came from. Let's look at another example. Is this graph proportional? Now it looks like maybe we're looking at someone's pay. So how much do you get paid? Well, for the number of hours that you work. So we want to know, is this graph proportional? And the answer here is no, this data on the graph is not proportional because it does not pass through the origin. The origin's way down here. So no, this is non-proportional because the line doesn't pass through the origin. And if you want to look at some of the values, it looks like 14, oops, I numbered these backwards. 114, this ordered pair is 218, and we have 322. So this would be 14 over 1, yet the second is 18 over 2, which is 9 over 1. So you can see these rates are not constant. 14 over 1 and 9 over 1. And I think now if I go back, I actually labeled these ordered pairs backwards. This is a half 3. This is 1, 6. And this is 1 1/2, 9. Now if we write these, 3 over a half, 6 over 1, 9 over 1 1/2, these all reduce to 6 over 1. So going back to the previous example, I wasn't looking closely enough down here and I labeled my ordered pairs backwards. They all reduce to 6 over 1. Here they would not. 22 over 3 does not reduce, so you can see that these three are not equal. So again, another reason why it's non-proportional. But you can tell just by looking at the graph. You don't have to do all of this with the ordered pairs, just look at the graph. In class, we'll work on worksheet 6.4.